The Premium Edition for civil engineers adds model-based design, analysis, and visualization capabilities for a complete building information modeling solution for infrastructure projects. This edition includes all of the products in the Standard Edition, plus AutoCAD Civil 3D and Autodesk 3ds Max Design, helping you to make better design decisions earlier. Improve your workflows by integrating your planning data to start the design process. Design and document more productively with intelligent model-based solutions that streamline time-consuming design tasks with specific tools and configurable standards. Improve the performance of your project with integrated analysis capabilities, including quantity takeoff and comprehensive storm and sanitary analysis. Help tell the story behind your designs with integrated analysis and visualization capabilities. With Infrastructure Design Suite, you can automate the process of turning civil data into more accurate, near-realistic visualizations with a push-button, easy workflow. Help validate designs, communicate design intent, and create compelling presentations for winning more work. Explore your options with model-based design. Better analyze designs with tools available in the suite, and deliver consistent and coordinated documentation. Using AutoCAD Map 3D, you have access to a variety of data representing existing conditions that can be used for creating compelling master plans for projects. In this example, AutoCAD Map 3D is used to aggregate data to produce a master plan for a proposed mall expansion. Starting with the basic footprint of the current mall and the proposed expansion, you can connect to the parcel information available as an ESRI SHP file from the local assessor's office. After stylizing the parcel, bring in additional GIS data such as hydrology, current surface contours generated from a point cloud captured for this project, flood zones, and both natural and built-up areas around the current project site. This information provides a holistic view of the current site and informs you of factors that might impact expansion development. This could be existing vehicle access to the mall addition or potential flood zones that might require drainage design. AutoCAD Map 3D also allows you to utilize existing as-built data in the form of CAD drawings containing information such as legal boundaries and easement areas that form the restricted zones that your mall expansion development will need to stay clear of. Also, bring in existing utilities that can serve the expansion. Using the query tools, you can query attached drawings to show the easements and utilities located near the mall. And using familiar AutoCAD tools, highlight the mall expansion zone for use in an exhibit that will support the master plan documents for this project. The planning information can then be shared with your design team. Since AutoCAD Civil 3D is built on AutoCAD Map 3D and shares the foundational geospatial functionality available in this software, information collected in the planning phase can be incorporated in Civil 3D for site design. In this example, you will address the site drainage requirements. Using surface data captured in the planning phase in the form of point clouds, you can build the existing ground surface, then style the surface by elevation to show low-lying areas. Then, analyze the natural surface water flow of the existing ground using the water drop tool and labeling spot elevations of the existing ground surface. Being able to work with the natural environment at the site enables better design that is more economical and reduces environmental impact. The natural undulations identifies the potential for a retention pond at the project site to cater for surface water runoff from impermeable built-up surfaces due to car parks and the new wing that is to be built. AutoCAD Civil 3D has 3D dynamic modeling tools allowing you to play with a variety of alternatives for the pond design by direct manipulation of the feature lines representing the pond surface. After calculating the volumes required for adequate performance under wet weather conditions, you can lay out the drainage pipes and catch basins that will take runoff water to the designed pond. The pipe model in Civil 3D are dynamic 3D objects as well, and can be taken into Autodesk Storm and Sanitary Analysis software, available with both AutoCAD Map 3D and AutoCAD Civil 3D. Using a predefined design storm for the region where the mall is located and using weather information local to the site, you can analyze the hydraulic and hydrologic performance of the current iteration of the drainage network. As it turns out, the current sizing of the drainage system is not adequate, something that is easily understood due to the visual nature of the analysis results. Using the animated profile plot function in Autodesk Storm and Sanitary Analysis, you are able to identify design flow capacity of the pipes and model alternative sizes to cater for peak flow. Having made the changes to the pipe sizes, you can run the analysis again to see that the updated sizes will work for this job. Being able to model and analyze performance in the design phase allows for rapid iterations of design alternatives, enhancing productivity in the design process. Finally, the updated model is brought back into Civil 3D, which in turn automatically propagates the changes across all affected elements of the model, including any documentation that was derived from the original model. The dynamic updates across the model is a huge benefit of the 3D model-based design process that forms the essence of the BIM workflow for infrastructure, saving time and effort compared to manual updates to design documentation. As you have seen, the Infrastructure Design Suite Premium Edition provides the ability to share information between the planning and design phases, coupled with the analysis capability of Autodesk Storm and Sanitary Analysis software. AutoCAD Civil 3D and Autodesk 3ds Max Design work together using a process that enables virtually anyone who works on civil engineering design projects to produce compelling visualizations of projects, regardless of size. To understand the design visualization workflow, you can start in a drawing that shows the preliminary design of a highway interchange and watch the engineer export their model using the Civil View Exporter from AutoCAD Civil 3D. Any or all design elements, including corridors, surfaces, and feature lines, can be exported in a single command execution. The exporter only recognizes the contents of the 3D civil model in AutoCAD Civil 3D and ignores standard AutoCAD drawing entities. The exporter is driven by a user-customizable configuration file that provides full control over the way that materials are assigned to the individual components from the Civil 3D model. Now import your model in 3ds Max Design using Civil View. Using Civil View, geometry is imported from the VSP3D file exported from Civil 3D. Individual components of the model can be selected for import, enabling you to selectively decide what needs to be imported into the visualization scene. By using the Use Feature Interpretation option, features can be assigned and managed automatically. Taking advantage of tools made specifically for civil engineering models, you can further enhance the model by adding content such as road markings, guardrails, lights, signs, and trees. All of these options are accessed through the Civil View Explorer. After road markings have been placed, the road marking object maintains a permanent dependency on the associated design feature from Civil 3D. Placement of static objects such as street lamps can also be placed relative to imported design elements. The geometry for these placed objects is derived from a customizable object library in Civil View. Once again, by default, placed objects have a permanent dependence on an imported alignment or feature line from Civil 3D. When a design change occurs, the locations of all associated placed objects will update automatically. In order to effectively utilize visualizations as part of the design process, it is essential that a visualization be able to react to frequent design changes made in Civil 3D. Using the Autodesk workflow, Civil View imported elements retain a permanent reference back to any imported Civil View VSP exporter files from which Civil 3D content has been derived. This means that as the project evolves and the design model is refined, design changes can be easily incorporated into the existing visualization. For example, if you update a portion of the Civil 3D model, you can simply re-export the model, overwriting the original VSP exporter file. In 3ds Max Design, you can choose to import only those objects that have changed. The dependencies built in result in an update to all related content as well. Impress your clients by taking a fully rendered animation of the preliminary design to a design review meeting versus a set of paper plans depicting 2D alignments and profiles. Even though the alignment and profile meet technical standards, a 3D visualization of the preliminary model provides realism and helps to identify environmental and safety concerns, as well as visual impacts that can only be seen by driving the roadway virtually. During the pre-construction and construction phases of a civil engineering project, collaboration and communication between design and construction teams are critical to success. You can bring together geometry and data created by multidisciplinary engineering teams into a single model. As shown here, design data from Civil 3D can be used as the starting point in Navisworks Simulate. Information from different stakeholders can then be added to create a more complete view of the virtual model. On your project, 2D utility information was provided by the utility company in a MicroStation DGN file. The 2D locations of the utilities can be used to identify where elevation information may be needed. A holistic view of the data gives you and other staff members the opportunity to explore the model in the unique ways that are important to each of you. Your engineering and construction teams can navigate through the virtual project, utilizing the rich 3D models produced in design, helping to gain greater visibility into the project, develop deeper insights into constructability, and identify and resolve issues virtually before breaking ground. Realistic navigation can be achieved with the use of gravity and the walk feature, which enables you to follow the contours of the modeled roadway and provides an eye-level perspective. In addition to visualizing the project, enhanced 3D models can be used to sequence construction activities. Your project engineers can visually simulate construction processes and 4D sequencing to help improve staging and scheduling, and to better direct field teams. This can help speed project completion by reducing idle time for workers. Let's see how Navisworks can be used to visually simulate construction processes and perform 4D sequencing to confirm our proposed construction schedule. In Timeliner, a schedule your contractor has prepared in Microsoft Project can be accessed directly by Navisworks. Once imported, a Gantt view of the schedule can be examined to view tasks scheduled with respect to each other. Once the tasks have been imported, model objects must be associated to the various tasks such that we can get a visual simulation of the construction schedule. To do this, an individual task is selected from the task list. Here, you can select a specific box culvert wall, deck, and wing walls. Once the task has been selected, the task type is defined. You are interested in the construction of the box culvert, so the Construct task is set. Objects from within the model that will be associated with this task are picked. With the selection complete, attaching the current selection is then executed. Then you can examine the simulated construction of just this box culvert. You can apply the same procedure to each task in the schedule, assignment of task type and selection of objects associated with that task. With all assignments made, you can run the full 4D simulation. Note that when elements of the model are under construction, they appear transparent, and when construction is finished, the object appears as it does in the final model. Overlay text showing the date, task, and completion percentage is displayed as well during the simulation. Since the schedule is not locked to the original MS Project file, schedule changes can be made directly in the Gantt view to perform what-if analysis. Whether a change to the start or end date is required, or an extension of time to complete the task is necessary, the change can be made in Navisworks. Time spent simulating and optimizing the schedule can help save money by reducing the risk of on-site delays resulting from unexpected scheduling problems. Other benefits include optimizing construction scheduling to reduce idle time for workers and heavy equipment. This saves not only time, but money for contractors. So, with better communication between project stakeholders, your projects can be built more economically and on schedule. The Autodesk Infrastructure Design Suite Software Premium Edition for civil engineers adds model-based design, analysis, and visualization capabilities for a more complete BIM solution for infrastructure projects.